So this is the kind of principal entry point into FRINX Machine. And when you click on Uniconfig, you see here a host of devices that have connected here. Everything from our netconf device to XR device, or netconf device directly via the native models, our XR connected via CLI and translated into OpenConfig. I have a Huawei device here, also translated into OpenConfig. And here I have a Junos device, also translated into OpenConfig. So what you see here is us, we went to the Junos device, we read the configuration via the CLI interface, and then we translated it into OpenConfig. So you see everything from the interfaces to some ACL information here. And here you can see the Cisco vendor-specific Yang representation. So we are completely model-based, and we have kind of read those Yang models from the device. We do that on the fly. We don't need any compilation for that. We're super proud of that. And as you see, we have an intent-based data store and an actual and operational data store. And you can load configurations into the intended data store, and then we can create the diffs and commit those to the network. So you'll see that in a little bit in full action. All right, so switching to the actual workflow view. So in this view, you see all the workflows that I've prepared for you today. And let me get started with something fairly simple. So here I'm going to show you that I'm going to connect to a device, and I'm going to execute a clear text command on that device. So there's no translation going on. There's no magic going on. All I do is I go to the device and execute the command. Here, this is the command that I execute, and here's the output that I receive. So similar to if you like Ansible or any scripts or Tickle scripts, you can just send anything and receive it, and then can do something with it, parse it, and act on it. So at its lowest level, that gives you full access to the device. And that's really useful to have. Now, what do you want to do? How do you do it if you want to talk to multiple devices, or kind of create actions across multiple devices? Let me show you this. So what I have here is a label. And we have the concept of labels. So we apply labels to devices in our inventory. And those labels, you can choose them. You can completely apply them yourself and then choose them yourself. And this allows you, a combination of labels allows you to choose a subgroup of devices from the inventory and execute a command on them. In this case, we want to get the configuration. So let me show you our inventory for a second. So those are the devices in our inventory. And if I give you a quick, see there's two devices that have the label classic. All right. Okay, so let's go back and execute this. And if we execute this workflow, we see what gets done here. There's a, there's some children spawned. There's a children process spawned that loops, through two devices, or retrieves two devices, and in a parallel way executes commands on those devices. So if I go back to the output of this, I see that I have retrieved the configuration of both devices. And at the end of the workflow, it was also stored back in our inventory. So let me look back in the inventory and refresh that. Okay, so what we see now here is the full configuration. So, those are the typical things that you do in a network. You kind of go around, retrieve your configurations, and push them somewhere in a repository. Can be Elasticsearch, but could also be Git. And we support that, of course, as well. So kind of the lowest level interaction with your network. But you can do it in 2 minutes. You don't need to write scripts and need to have folks maintain scripts and playbooks and all that stuff. So that's all comes out of the box, all that functionality. Okay, now I'm going to show you how we can parameterize a little template that we send to the device. And for that, we first have to kind of create that template. So let me do that. So there's a little snippet that I'll take here and that I'll put in here. And you'll see there's a variable in here, this interface number. Okay, so let me create that and go back to the inventory, and I have my commands in here. All right, and you see we've just created this here, interface number, and so on. So let's use that template and kind of create this configuration. So use that template that we just created and push it on iOS 03 on that device and pass the variable interface number and make it 77. Okay, so let me push that. Let me kick off that workflow. What we see here in the output of the workflow is how we've kind of applied that configuration. And if you look on the actual device, then we see that we have an interface loopback 77. Okay, all right. So well, that's useful. Now we can do sending templates of clear text configuration with parameter substitution. So very simple scripts, and everything that you want to apply to the device, you can apply. Now comes the more sophisticated stuff. I want to show you our workflow builder here. And so this is the interface that you use or you can use to kind of create new workflows. So you just simply drag some elements in here and you connect them. And what I'm going to show you here is how we create an ACL. So there's a couple of steps that we apply here. First, we sync from the network. So we read the configuration of the network device. Then we're going to make sure we work on the most recent version of this in our config data store. And then here we write a configuration to the device. And that configuration is not written in a device-specific language, but it's written in OpenConfig standard. So this allows you to take this template and apply it to a Cisco, a Junos, a Huawei, a Brocade, a Arista, whatever device we have in our library. And we can apply and translate those for you to those devices in our library. Or if the device speaks OpenConfig right out of the box, you can apply it directly. So here we still have a variable that we want to substitute when we actually run it. And then once we do this, we commit at the end, and then we read what we have sent to the device. Okay, let's execute this. Let's substitute IP source with this address. Ethernet 2 is the, and then we watch how we execute that workflow. All right, so we go through this step by step. The workers do their job. Now we are committing it to the device, and finally we read the configuration. So let's see what's in the config, what's in the journal. So you see there's a bunch of stuff that I've done over the last hours or so. And here we have the specific device-specific command that we ultimately send to the device. We know it's an iOS flavored device. We need to kind of transform that OpenConfig into this specific command and push it to the device. So let's see if it has arrived at the device, if the device is configured correctly. And indeed, so we have under Gigabit Ethernet 2, we have now an access list with the source address that we've specified. So now this becomes really useful, because not only can I push this on a Cisco device, but also on a Junos device or any other device, in our library or that speaks OpenConfig. And I don't have to change my provisioning tool or my service flow to do that. So that's pretty cool. Okay, going back, let me remove this again. Delete that ACL. So the deletion works pretty similar as the application. So it's the device, it's the interface. I don't need to specify the variable anymore. I just remove it. And so I go through all these steps, and it gets committed. And once we see in the journal, once we watch the journal, we can see that we have removed that from the device. So we can track all this back. This is available as long as you want. And let's look on the device itself. Okay, and now there's nothing anymore on Gigabit Ethernet 2 and no more IP access list. All right, so that's kind of useful. You can now apply things completely stateful across different devices and so on. All right, so next step is apply something across multiple devices. I'm going to show you this layer 2 VPN. So I have a layer 2 VPN that I want to apply point to point in this case, and it's done with this workflow, and it has a little, message that it sends at the end of it. Let's go through this. All right. Let's watch how this executes. So we read from the devices. We, make sure we replace it with the most recent version. We configure both sides, both ends of the device, and configuration attempt succeeded. We push it, we read the journals, and we are done. All right. So this helped. This allowed me to provision a layer 2 VPN point-to-point service. And again, it's done in a way that it's not device dependent. It's an open config template that I'm using and that I'm translating in the controller. So we think that's pretty cool. All right. Here is a couple of other things that I want to show you on the FRINX machine. So if you want to create some little logic right in the workflow, if you don't want to create a worker task, but if you want to do it right in the workflow, we have this Lambda task here. And this Lambda task allows you to put some JavaScript code in that's executed on the conductor server. And here I'm going to show you an example. I'm going to go to iOS 1, that device I've mounted, and I'm going to read all the devices from it via CLI. I translate it into OpenConfig, and then this little Java snippet matches the description foo. So it looks for a description foo and tells me which interface has the description foo. All right, so in this case, the result is Gigabit Ethernet 3. So the output of this workflow is Gigabit Ethernet 3. And where would you use that? Typically, if you have a device, you deploy it, you would kind of initialize it with all descriptions on all interfaces unused or available. And then once you attach customers to it, you would put your customer names in the description. And so this little workflow allows you to kind of just pick the next available interface. You match unavailable or match available or match whatever string you'd like. And you get the next interface that you can use in your provisioning flow. So this is the most accurate way to really interact with network devices. You're not dependent on some out of sync single source information. You can get it directly from the device's single source of truth. All right, so the cool thing we think here is the capability that we can also use other devices. So this is the Huawei device. And so we are reading from the Huawei device, and we also see all the interfaces in exactly the same format, like we did from the iOS device. So we can use the same match, script for this Huawei device. And now let me try a Junos device. So this device is mounted here, and so we read the interfaces from Junos, and it's the same, the same data structure, exactly the same data structure like with the previous devices. And the output here, because I also have that foo description on an interface, is the interface name of that Junos device. All right. Last but not least, I want to show you a decision criteria in these workflows. So here is a little workflow that shows our capability to do validation. We can do complex validation against JSON schemas or like all kinds of validations, programmatic validations that you can think of. But also if you just have like a simple decision path, we have this little tool in here. And what we are doing here is we just check if this device is mounted. And if it is, then we get a little message here from Slack and it says, Eureka, this thing is on, it lives. And if I try this again with a device that I know is not on the controller, then it says, oops, this one is not mounted. And as you see here, this thing, checks, it says, hey, checked, but it's not there, and then it sends it to Slack. So everyone can create workflows without knowledge of complex coding techniques. You can use code in the background. So if you want to apply code, there's no problem in doing that. But even for your next higher tier of personnel, they can interact with this and do something useful really, 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 really fast. All right, let me switch back to our presentation.